Hey everyone, so a quick review on something we probably haven't seen since college algebra, possibly before, which are piecewise functions. Piecewise, all this means is that two functions or more have been stitched together into a single function. Usually, these things are kind of man-made. They don't necessarily follow a natural phenomena, but they can be really helpful. So here's an example of just a simple one that's got two pieces. The way that we read these are y, the output value, takes on this rule for these input values. Okay, so it kind of does this when this is true. Okay, so when the x values are less than 4, it's the line 2x plus 1. And when the x values are bigger than or equal to 4, it's acting like this parabola x squared minus 7. All right, so to get a sense of what this thing looks like, let's start off a little sketch here. And so the kind of breakpoint which we see here in the input rule or the domain over here is at x equals 4. So we'll say here's like 4. So before x equals 4, this thing's acting like this rule, 2x plus 1. Now to graph a linear function, that might also be kind of rusty, but just remember you need the slope and 1 point. So I know the y-intercept is 1. That's like here, and it has a slope of 2. So what happens is it's at 1, it goes up 2 over 1, up 2 over 1. So when it gets to 4, it's at the point, 8 plus 1 is 9. So around a height of 9 as it traverses this point. It doesn't actually equal it at that point. But for all values before this, it's acting like this line. Here's y equals 2x plus 1. And it kind of has this road stop. And we say, well, now that x equals 4, we're actually equal to the parabola x squared minus 7. What does x squared minus 7 look like? Well, it's a parabola. It's upward facing, and it's shifted down by 7. But, at the value x equals 4, where this kind of handoff is, for the input, that at x equals 4, it's at 4 squared minus 7, which is 16 minus 7, which is 9. So I built it so that it actually links up here and then carries on doing parabolic things, right? So it acts like a parabola. So over in this wing, it's the parabola, x squared minus 7. And over here on these x values, it's the line 2x plus 1. That's a rough, quick overview of what these things look like when we graph them. And to go the opposite direction, if I had a request to, let's say, find a formula for the following, and we have something like this, and let's say it does this and then that. And we know that we have the points here. Let's say this is 3, 0, and this is 0, negative 6. And we know that this is the point at x equals 2. Okay, so we want to figure out, what is the formula for this function? Well, it's got two pieces. It's got this piece and then this piece, right? It's not one part. It looks like two linear functions. They're not always going to be linear. I'm doing this because it's easy to make up off the top of my head. So here for this piece, we got to figure out what input values is this, because we're going to break it up into rules, right? When this is true, I'm on this leg. Well, this is the line y equals negative 6, and it's true for x values less than or equal to 2. So we'll say for x less than or equal to 2, I'm the line y equals negative 6. And then when I hit this x equals 2, what happens? I switch to a new rule where now I'm on this slanted line. And the slanted line crosses through the point 2, negative 6, which is right here, and the point 3, 0. So I'd come up with the formula for this line, which if I use point slope form, is going to be the following: y plus 0, right? Y minus 0 equals m. The slope here between these two is what we need. So that's delta y over delta x. So the change in y is upwards of 6 over a change in 1 in the x direction. That's slope of 6. So this is really y equals 6 times x minus 3 if I use point slope form here. Okay. So this represents this line here. I kind of made that hard to see. Back that up. But that's this line here. And then we got to say when that when the inputs are, what inputs we're using for this, geez Louise, is x greater than 2. Okay, and so that's for these x values up here, x greater than 2. Sometimes this breakpoint is important, sometimes it's not. Sometimes they're not going to be meeting. Sometimes there will be a jump, what we call a discontinuity or a step, and that's okay. We have things that we do with that in particular, but this is how we kind of go both ways, from the formula to the graph and from the graph to the formula. Obviously, different function families are going to be invited here. And when we're working with exponential functions, we'll need to be able to find the formula for an exponential function or a power function from the graph to be able to do that. So that would be the skill you might have to deputize here. Okay. So I hope that's helpful as a very, very fast review of piecewise functions. I do have more resources on that, so just get in touch if you need those.